And as for the chemostat, we already learned the definition, importance, and the key parameters of the chemostat itself. So especially for the chemostat, the dilution rate is the most important things that we have to consider, and how to determine the dilution rate. We need to calculate the specific growth rate of the microorganisms first. So and then we also learn about the mathematical modeling and then example of calculation and application of chemostat. And then again, if you want to rewatch the last week lecture, and our department provided the YouTube channels, and then you can rewatch it again. And I'm so sorry, it's not lecture one. It should be lecture two. It's about the continuous flow bioreactor or chemostat, and you can rewatch it. So we already provided there. So this is just a brief descriptions of what we already learned about batch fermentation bioreactor and ideal chemostat as well. So here we want to have like the steady state condition for the chemostat. Then okay, for today, we have the special guest. I think Usman already joined here. Hi Usman, how are you? Can you hear me clearly? Oh, I think you're still muted. No, we actually cannot hear you. Oh, there is a technological issue here. So, okay, I would like to introduce Usman. Usman is a postdoc student in Washington State University, and he graduated from Washington State University, graduate PhD in Washington State University. And especially for today, Usman will give a talk about anaerobic digester, that specific bioreactor, especially for anaerobic digestion. And Usman also will present like what's the applications there and types and the functioning of the biogas plant, operations, maintenance of biogas plant, and then potential problems and likely solution. That's so interesting things because we already know about the anaerobic digestion technology, anaerobic digester, and then we will learn again in oh, so now you're good, Usman.
Yeah,
All
got
right.
it.
Yeah, how are you?
I'm doing good. What about you?
I'm doing good. Long day today.
Yeah.
Sorry for
I-
being late today. We actually have daylight saving time, so I actually didn't know like earlier, 1 hour earlier, right?
yeah.
We actually should start it at 5 p.m. here in the United States, and then 8 a.m. in Indonesia. So I think we already have like 59 participants. That's great. So I really hope that everyone here enjoy our our lecture.
Yeah,
So
should I share the slides or somebody from Indonesia will share the slides?
oh, I think you can share the slide. Have you prepared for the slide, or you joined by phone, or you joined
I
by
actually
computer?
joined by phone, but no issue. You can email me the link on Yahoo
Oh,
email. Find it, no problem.
okay. So your WSU email?
No, the same email, the Yahoo email from which I
Oh,
have my
okay,
lectures.
sure.
You can just email me the link, then I can join.
All right, all right. So probably we need the time a little bit, okay?
No problem, no problem.
Sure.
In the meanwhile, I will introduce myself, okay?
Okay, sure, sure. Thank you.
Yeah,
I will email you now. Okay.
yeah, yeah,
Can talk
yeah.
now. Sorry.
Yeah. Okay. Thank you very much, Buddy, for giving me a chance to talk about anaerobic digestion. I am Dr. Muhammad Usman Khan. Basically, I am from Pakistan. I have done my master and bachelor and PhD in agricultural engineering. And my expertise is in bioenergy. And today we are going to discuss the main technology, one of the bioenergy technology, which is anaerobic digestion. And In this lecture, we will discuss some basic things, and most of the things will be from practical field side. Instead of lab work or basic definitions of anaerobic digestion, we will base most of the stuff we'll discuss from the fields, from the biogas plants. What are the issues, what are the common problems, why the technology is not successful in Pakistan as well as in Indonesia. So these are all the issues which we will discuss. I think definitely there will be some faculty members from Indonesian side who have expertise in bioenergy, and we can discuss the common issues which are going on uh, regarding the spread of this technology. What are the issues, why it is not being flourished in Indonesia, same like Pakistan, and what's the ongoing issues with the technology.
Oh, I actually already sent the link. Have you received it or not yet?
Yes,
Okay.
I received it. I
Okay,
received it.
so sure,
Yeah,
sure. Thank you.
I'm just launching the issue. So
Okay, thank you. Probably you can switch to your computer now, right?
yes. I'm switching to the computer,
Okay.
and then I will share the screen as well.
Okay. Thank you so much. Thank you.
So in the meanwhile, we can discuss some of the things that like what is anaerobic digestion,
Sure.
because the screen is sharing. It may take a while. I have an older version of Zoom, and might be the link is from the new version, so it is updating. Yeah. So what is anaerobic digestion? Anaerobic digestion is a biological process during which the microorganism break down the organic waste and produce biogas as a cleaner energy source. And during this breakdown, beside biogas, the microorganisms also produce a waste, digested waste, which we will name as slurry or organic manure. So basically, during this process, there will be two products. One is biogas, and other will be the slurry or organic manure. And this type of technology is why this technology is considered effective or cheaper than the other technologies like gasification, pyrolysis. There are many bioenergy technologies, but this technology is considered effective or cheaper because it is basically economical compared to the other technologies. Let me share the slides.
Can you share the screen now? Or
Yeah, I'm sharing.
okay.
Recording in progress.
All right, we can see our presentations here.
Okay.
Oh, there is the echo. Probably you used to.
Yes,
you
that's
need,
why I'm muting. I'm muting from the computer.
okay. You need to mute one of them, I think.
Yeah.
Yeah, yeah, yeah.
Budhi, is it okay now?
There is the echo still. I don't know, like probably you need to mute one of them.
I have already muted.
Oh, all right. So, but there is the echo. I'm not really sure. Can you talk again?
Okay.
Oh,
Again.
there's the echo.
Okay. Can you share the lecture from your side, and I can turn off the computer.
I think I can share the screen now. Can you end the screen, Usman?
Yes.
Because you still share the screen now, so I need to change it. Okay. Okay, all right.
So from the computer, I am leaving.
All right. Here I know that is it too small? Hold on. Let me make it bigger. So yeah. Can you see it?
Yes, I can see it.
All right.
Thank you
We can
very much.
start it from the an overview, right?
Yeah, an overview anaerobic digestion. So as we have already discussed what is anaerobic digestion. Anaerobic digestion is basically a biological process during which the anaerobic microorganism break down the organic waste and produce two products. One is biogas and other is digested organic waste, which we call it as slurry. Next, Buddy. So here is, if you see this slide, here is a biogas puzzle, how the process takes place, what are the products which are being produced during this process, and what type of materials we can use as a feedstock for a biogas plant. So we can use, if you see the upper side of this puzzle, the upper half circle, these are all the materials which can be used as a feedstock for the biogas plant, which includes cattle dung, agricultural products like energy crops, crop residue, and manure. Beside these agricultural waste, we can also use organic fraction of municipal solid waste. We can use household waste, landfill waste, and sewage sludge. These are the feedstocks or the materials which can be used in the biogas plant. And as a result of digestion of these products, we get two products. One is biogas, which is shown in green color, blue color, and other product is digestate, which is shown with yellow color. So biogas can be used for cooking, heating, lighting, and running an engine, as well as it can be used for flaring process, whereas the digestate can be used as a clean biofertilizer or contaminated biofertilizer. Why I have used a word contaminated biofertilizer? Because if you are using sewage sludge as a feedstock in the biogas plant, there may be some contaminants, some chemicals from the industrial sludge, which are producing a contaminated slurry or contaminated biofertilizer. So most of the countries, that is why, have banned the usage of sewage sludge uh, digested sewage sludge as a fertilizer, but most of the developing countries, they are still using it as a biofertilizer. So these are the basic two products, but nowadays the biogas has a very common use, especially in Europe. It is being upgraded. There are basically two products in the biogas. One is methane, and other is carbon dioxide. If you want to use the biogas as a fuel, you will have to upgrade or remove the carbon dioxide from the biogas. That process is called pretreatment or upgradation process of biogas. The upgraded biogas can be used as a gas grid, buses, lorries, private cars, and agricultural machinery as a fuel. Next slide, Buddy. If you see the next slide, in this slide, basically I have shown you the process, how the anaerobic digestion process takes place inside the biogas plant. Basically, there are 4 steps which occur during the breakdown of organic waste and during the production of methane as a product. The first major process is hydrolysis, in which the breakdown of organic material takes place. And during this process, the larger organic materials are converted into smaller products like sugars and the monomers of sugars. And then after that, another bacteria produced on these sugars, which eat those sugars and produce acids, which we called as VFAs. And these bacteria are called acidogens. And after acidogens, there is a third process which we call it acetogenesis. During the process of acetogenesis, the acetogenic bacteria, they eat the VFAs and produce acetic acid and hydrogen. And which in the next step, the methanogens or methane forming bacteria eat those acids and produce methane and carbon dioxide as a byproduct. Next slide, please. So in the next slide, if you see these are different types of biogas plants which are being used in developing world, especially in Asian and African region. So the biogas plants are divided on the basis of gas holder. On the basis of gas holder, they are divided into floating gas holders and fixed gas holders biogas plant. And similarly, they are also divided on the basis of feeding material, feeding strategy. On the basis of feeding strategy, they are divided into continuous feeding as well as the batch feeding. And on the basis of method of installation, they are divided into prefabricated or constructed inside. So next slide, please. If you see the next slide, now I have taken the pictures from different parts of the world, which are the common designs which are being used in different parts. So this is a common type of biogas plant. It is named as floating type biogas plant, and it is also known as Indian biogas plant because floating drum, first of all, was used in India, and an organization of India, which is named at Quick, have developed this biogas plant. And Quick is an Indian organization which is called as Khadi and Village Industrial Commission. And in this type of biogas plant, there is a floating gas holder. As that breakdown of organic waste takes place inside the digester, it produces gas, and with the gas pressure, the drum moves upward. Or when the pressure of the gas reduces, the floating drum goes downward. The main advantage of floating drum biogas plant is that the gas pressure during this biogas plant remains constant. If, for example, you have this type of biogas plant at a distance from your house, and you are using that gas for cooking purposes, if the gas inside the main drum, which is we call digesting pit, if the gas amount reduces, the drum will move downward and the pressure will remain constant. That is why this floating drum biogas plant is also called as constant pressure type biogas plant. Next, please. This is another type of biogas plant, floating drum. It is the same as the have seen previous one, but this is from the Nepal, but they have some kind of modification in quick biogas plant. They have added, instead of going slurry directly into the outlet tank, there will be 4 to 5 parts in all of the biogas plants, which I am going to show you. The first one is the digestion or digester. Digestion tank or digester, this is the central part, and there is this part is called the number 3rd. This is called feeding tank. Number 4th, this is called outlet tank, and number 5th is the gas pipeline. So what is the difference between Nepali biogas plant, floating drum, and Indian? They have a divided in the digester. In Nepal, they mostly make a central wall inside the digester, and they have observed that this divider not only help the mixing of material, make the mixing of material easy, as well as digestion is more complete compared to the one biogas plant in which there is central dividing wall is not present. Next, please. So here, if you see, these are the advantages of this type of biogas plant. This is constant pressure, and this biogas plant is suitable for larger plant, easy to understand. But the main disadvantage is that because the drum, which we have seen that the gas drum, it is usually made of steel. That is why it is very expensive and cannot build in remote areas. For example, if you have a hilly area or remote area where there are not too much access of the material, it will be difficult to construct this type of biogas plant in hilly areas or remote areas. Similarly, another disadvantage of this type of biogas plant is it requires regular maintenance, because if the drum has not gone through a painting process after every year, the hydrogen sulfide which is present in biogas plant, that may cause the rusting of the drum, and that may deteriorate the drum. And similarly, this type of biogas plant is sensitive to temperature changes, because the drum is already open to atmosphere. If there is more severe weather, high temperature or very low temperature, the microbes inside the digester will be disturbed due to that severe changes of weather. Next, please. Now, after floating drum, I will show you some of the pictures of another type of biogas plant, which is fixed dome biogas plant. This type, before going through the pictures from different regions, this is the most common type of biogas plant which is being used in Indonesia as well. So this is the first picture. This is from China. And this type, as the floating drum biogas plant, I have told you that biogas plant is also called Indian type biogas plant, because floating drum was first developed in India. Similarly, the fixed dome biogas plant, it is also called Chinese biogas plant, because fixed dome biogas plant was first developed in China. So this is a picture from China. It is a fixed dome type, but this fixed dome type also varies from region to region. For example, if you see the gas holder of this biogas plant on the upper side, the number 2 section in the figure, the gas holder is fixed. So this type of biogas plant, the major disadvantage of this type of biogas plant is that when there is low gas production inside the digester, the pressure in the remote areas or the houses which are located at a distance from this type of biogas plant will face the problem of lower pressure. But this problem is not present in floating type biogas plant, because in those biogas plants, the drum can move upward as well as downward with the increase or with the decrease of gas. But in this type of biogas plant, the drum is fixed. That's why they are called constant volume biogas plants. Next, please. So if you see the next picture, this one, the same fixed dome type biogas plant, but this picture is from Tanzania. What is the difference between this picture and the previous picture? If you see the previous picture, the Chinese biogas plant, the dome was not completely going down to the ground, but the Tanzanian biogas plant, they have taken the dome, curved shape of the dome to the ground. But in Chinese biogas plant, there is a wall on which the dome or the arc, that is called arc, and this is called dome. Okay, so this is more curved compared to the Chinese biogas plant. Next, please. If you see the next picture, this is from Nepal. It is actually the same as the Chinese biogas plant, but the major difference between the Chinese biogas plant and the Nepali fixed dome biogas plant, they have added another part which is called as manhole. Instead of gas, the digested material directly go to the inlet tank, it will instead will go into the manhole, and then from manhole it will go to the outlet tank. Beside this, an interesting fact about Nepal is that they prefer to use they prefer to connect the toilet with the biogas plant. This is an interesting thing about Nepal. While in Indonesia or Pakistan or Bangladesh, they are using only dairy waste or other waste in the biogas plant, and they have only one inlet. Most of the biogas plants in Nepal, they have two inlets. One is manure and other is human excreta or toilet waste. So this is very common in Nepal. Next, please. So if you see the next picture, it is from Bangladesh, and it is basically the same as the Chinese biogas plant. They're also using arc, and the arc has walls on both sides. So, but the major difference between Bangladeshi fixed dome and the Chinese fixed dome is that the outlet tank is also arc type in Chinese biogas plant, whereas in Bangladesh, they are making a rectangular outlet tank as compared to the Chinese biogas plant. Next, please. So if you see the next one, this is from your country, Indonesia. This is actually a combination of Chinese and Tanzanian biogas plant. The dome or the digester is basically the same as the Tanzanian. They have no walls on the no wall side wall. Instead, they are also making the dome. And similarly, the most of the outlet tanks they are also making as a dome type. Next, please. So if you see the next one, it is Vietnamese fixed dome biogas plant, basically almost similar to the Indonesian type, but they are making a different type of outlet, somewhat combination of arc type as well as rectangular type. Next, please. And after the Vietnam, this is from India. India is actually making this type of biogas, fixed dome biogas plant. They have named this Deen Bandhu biogas plant. What they are doing, they are making the bottom of the biogas plant also curved as the dome is curved, but they are making the outlet and the inlet as rectangular. Next, please. So what are the advantages of this biogas plant compared to the previous one, which we named at Indian biogas plant? So the basic advantage of this type of biogas plant, this is underground structure, and it can bear the severe weather or temperature changes will not disturb the bacteria. On-spot construction and durable, the lifetime of the floating drum biogas plant is usually 10 to 15 years, whereas the fixed dome type biogas plant, it has a longer span or longer life compared to the floating type, and it has usually the life of 20 to 25 years. But again, there with this advantage, there are some disadvantage as well. One of the advantage we have already discussed, that there is pressure fluctuation when the gas will be lower inside the biogas plant. The pressure of the gas will also be lower. Similarly, the construction material is expensive, and beside this, an expert member is required for the construction of this type of biogas plant. Next, please. So this is another common type of biogas plant. This is called as plastic or bag digester. In this type of biogas plant, the gas holder will be made of plastic, or sometimes it is also made of rubber as well. And we will, in this type of biogas plant, usually well is constructed inside the ground, and then over that well, we use a plastic membrane or rubber membrane to hold the gas which is being produced during anaerobic digestion. The basic advantage of this type of biogas plant is that this is cheaper compared to the fixed dome as well as floating drum biogas plant. But the disadvantage is that the temperature fluctuations may cause more changes in this type of biogas plant compared to the dome type as well as the floating drum type biogas plant. Yes, please. Next. Okay, so there is some of the picture from different parts of the world. This is a plastic bag digester. And next, please. This is another plastic bag digester. They have used some kind of resistance over the protection over the digester, because there is a common issue with this type of biogas plant that if some stray animal or the children, they usually picture this type of biogas plant. That's why they have used a protection of bamboos, so that if there is a stray animal, cannot go inside the digester or cause the leakage problem in the digester. Next, please. And this is also some of common types which are being used in different parts of Asia as well as in Africa. Next, please. This is another picture from Vietnam. They are also using the plastic type biogas plants in Vietnam. Next, please. This is the picture from South Africa, Rwanda, and this type of common biogas plant is also common in African region. And these are some of the advantage and disadvantage of this type of biogas plant. The biggest advantage is the cost is lowest compared to the other biogas plants, which we have already discussed. And in this type of biogas plant, the well or the digester do not need a lot of work. Instead, a shallow digging work required. Very vulnerable to damage like stray animals as well as the children. And it requires frequent repairs, low gas pressure, limited lifetime, usually less than 2 years. And it is very sensitive to temperature changes. So this is a new type of biogas plant which we named as prefabricated. It is very common in China as well as some African countries. And the biggest advantage of this type of biogas plant is that it is very easy to install. And secondly, it is compared to other types of biogas plant, it is considered cheaper. And this type of biogas plant is first of all discovered or developed in China. And there are many companies in China who are developing this type of biogas plant by using different types of plastic waste material. It is actually, I have contacted some of the Chinese companies who are developing this biogas plant regarding one of my project back in Pakistan. And it was interesting to know that they are developing this biogas plant by using plastic waste instead of using fresh plastic. Next, please. And these industries or the companies, they are making this prefabricated type biogas plant according to the size. For example, the company which I have contacted in the past, if you want to make 10 cubic meter biogas plant, you have to use one section. If you have to make 20 cubic meter, you can use two sections. And similarly, with the increase of cubic meters or the size of the biogas plant, you can increase the number of sections. And the best advantage for this type of biogas plant is that easy to construct, and it is lifetime is almost similar to the one which we have discussed, the fixed dome type biogas plant. Next, please. This is another prefabricated type of biogas plant. The previous one in the previous slide, which we have discussed, that is actually the horizontal type prefabricated biogas plant. And this one is the vertical type prefabricated biogas plant. And if you go to the next slide, this is the Chinese type smaller biogas plant which are being used, very common in China, and this company is also exporting it to the other parts of the world. This is a common type of biogas plant of 10 cubic meter size. And at this biogas plant, if you can set it up outside of your house, it can easily fulfill the requirement of 6 to 10 family members' cooking requirements, as well as the other energy requirements. Next, please. This is a prefabricated biogas plant from Agama, South Africa. If you see this type of biogas plant, almost similar to the Chinese one, but they have used different section and different types of plastic compared to the one which we have seen in the previous picture. Next, please. And this is another type of biogas plant. I think it will be common in Indonesia as well, but in most of the those areas in Pakistan where the water table is higher. Similarly, if you have the issue of constructing all these biogas plants, which we have discussed previously, in any part of Indonesia where the water table is higher, we can construct plug flow type biogas plant in that region. Instead of digging the well vertically, we usually make a horizontal well, and upon that horizontal well, we make a dome. You can make the dome, or you can use a membrane. And this type of biogas plant is called plug flow type. And once again, this type of biogas plant is preferred in those areas where the water table is high. Next, please. This is another type of biogas plant, ceramic SSD, and this is also prefabricated type. And the next one, please. This is another type of biogas plant, which is named as solid state digestion biogas plant. This is also common in some parts of Pakistan. Similarly, this is next, please. Medium scale biogas plant, and these are common. These are some of the pictures from different regions of Pakistan. Next, please. This is a medium gas holder floating drum biogas plant in Punjab, Pakistan. Next, please. This is a very good technology which is very common in the developed country, and it is the need of the hour to adopt this technology in Indonesia. In Pakistan, I have done one project, and we have made three biogas plants in Pakistan, which are more than 1,000 cubic meter. And instead of why this is preferred, and why I'm advising that this should be adopted in Indonesia as well, because if you are constructing a biogas plant of more than 100 cubic meter, 200 cubic meter, 300, 400, 500, if you are making a structure under the ground and then you have to make a dome, it will be very costly. For large capacity, to making a dome is very costly, and the cost of construction will increase a lot. In that scenario, this membrane is preferred. It is actually a constructed of two rubbers. One is inside and other is outside. And in between the two rubbers, there is the air pressure, so that the temperature changes doesn't affect the reactor. Next, please. This is the sectional view of one of the biogas plant which was made in Pakistan. If you see the membrane gas holder, it is full of gas, and it is actually working very well in Pakistan. Next, please. This is a hybrid biogas plant which was made in Pakistan as well, and in this one, we have constructed the fixed dome biogas plant, but it was for an industry, and it was a large biogas plant, and they also want to use the gas, store the gas. That's why we made an external gas holder as well. So that's why it is named as hybrid fixed dome digester with external gas holder. Next, please. So here are hybrid fixed dome digesters from some other part of the world. Next, please. This is 30 cubic meter plug flow digester in Nepal. Next, please. Medium scale biogas plant in Vietnam. Next, please. This is from Rwanda, 150 cubic meter. And they are also preferring the fixed dome type biogas plants. Next, please. This is 100 cubic meter biogas plant, which was in Tanzania. Next, please. Another 100 cubic meter biogas plant from Rwanda. Next, please. This is a 50 cubic meter biogas plant, fixed dome type, which was constructed in Sri Lanka. And this is a plug flow type biogas plant. It was actually in a region where the water table was higher, and we prefer. This is actually asked by Nestle company, who was working on dairy waste, and the water table in that area was higher, and we advised them to construct a plug flow type instead of fixed dome type. And these plants are working very well. Instead, they are giving good gas because dairy waste is actually have a higher methane potential compared to the other types of waste. Next, please. This is 1,000 cubic meter, and other types of biogas plants, 100 cubic meter in Pakistan. This is, and the next one is 1,000 cubic meter membrane type biogas plant, one of the region in Pakistan. And next is the picture from 1,000 cubic meter. This is why the India is progressing more in this technology, and they have recently constructed 1,000 cubic meter biogas plant, which will work on solid waste instead of manure or dairy waste. They have started producing biogas from solid waste as well, which is not common in Pakistan as well as in Indonesia. Next, please. So after that, there are some of the plants which we have constructed in Pakistan. This is 50 cubic meter. Next is 75 cubic meter. Next is 100 cubic meter. These are some of the projects which we have done. 50 cubic meter. Then during these projects, we have taken some of the pictures from the fields. This is the pictures for fixed dome and plug flow type biogas plants. And after the major purpose of mine to show these pictures to you, that why this technology, what are the outcomes, and what lessons we should learn, what are the take away home lesson for us. Please, when you are designing a biogas plant, keep the following thing in your mind. First of all, availability of construction material should be very easy on that point, and required construction skills should be present. User friendly. Always make a biogas plant which will be user friendly. And soil conditions must be checked. Groundwater table must be checked. Initial investment and maintenance cost should be checked. Anticipated use of the biogas should be checked. Performance or destruction, removal of volatile material, all things should be checked. And the best of all, user level of acceptance. User level of acceptance, that if you are constructing a biogas plant for a farmer, first of all, please satisfy him. Try to motivate him that this technology is best. Let him know what are the advantage of this technology. Next, please. This is a basic process of biogas plant. A household farmyard waste. It will come into the cattle dung and then biodigester and then biogas upgrading process, CO2 removal, H2S removal, moisture removal, and then the gas is going to the engine, and then it's running the engine, or you can use it as you can store it in a storage tank. Next, please. So this is for common practice or the common calculator which I have made for the students as well as for mine. If you have constructed a 20 cubic meter biogas plant, please keep in mind that it will, if you want to run a generator, it can only produce 50 units of electricity. And if you are producing biogas, not producing electricity, it can produce 8 cubic meter. If you require 8 cubic meter gas, you will suggest the farmer or the person who want to install the biogas plant that you should go 20 cubic meter. If we need 16, if you have 40 cubic meter, you will get 16 cubic meter of gas. And if you have 50 cubic meter, you will get 20 cubic meter of biogas. A simple think that 40% of the size of the biogas will be the gas. For example, 40% of 50 is 20. It means if you need 20 cubic meter biogas, you will suggest the farmer or the industrialist that he should construct a biogas plant of 50 cubic meter. Next, please. So these are different types of components. I will not go into the detail because we have some more slides. So these are all we have already discussed. And yes, next, please. Next. So this is actually these slides were from the biogas plants which are being used in different parts of the world. And if you, Buddy, can go to the operation and maintenance of the digester, that would be wonderful, because
Okay.
I want to go a little bit quick so that we can have more discussion why this technology is not being flourished in developing countries.
Hold on, I need the time to download it first. The problem and solutions, right?
No, the operation and maintenance.
Oh, operation and maintenance. Okay. Let me check. Oh, it's still downloading. Oh, wait. Yeah. Oh, I don't know. There is a problem with internet here. The problem
No,
and so okay. Now I can
operation and
reading.
maintenance.
Okay. Hold on. Okay. Can you see it?
Yes, I can. No, this is problems and solutions. I'm asking you about the operation and maintenance.
Oh, okay. Here. There we go.
Yes, thank you so much.
Yeah, no problem.
Share it.
It's already shared, right?
Okay, thank you.
Okay.
So, dear audience, this is these slides I have specially made for you guys, because the major reason of failing this technology in Pakistan as well as in Indonesia is the major concern operation and maintenance. So in the previous slides, we have only discussed some of the types of biogas plants around different parts of the world, especially in Africa and Asia. And the major reason of failing this technology in Indonesia, in Pakistan, is operation and maintenance. So here I want to let you know why. For example, the construction is the first task in biogas plant development. And in our region as well as in Indonesian region, the most common type of biogas plant is fixed dome type. And fixed dome type biogas plant required an expert mason. But most of the plants which are being constructed in Indonesia and Pakistan, they are being constructed are normal mason, which doesn't know, who have no speciality in construction of biogas plant. That's why most of the plants fail after 1 or 2 years. Besides the construction, the operation and maintenance, we are even if the plant is constructed by us, a technical or expert mason, we should give the knowledge to the farmers. We should give a training to all the farmers who have the biogas plants. I have done one project, and in that project we have constructed about 30 biogas plants in Pakistan, in Punjab region. And then we carried out a training in different regions of that area. And believe me, that project goes very well. Before that, the government started many projects regarding the construction, but most of the programs, same like Indonesia, I have gone through many papers. Government has started many programs in Indonesia, but the most of the biogas plants, they usually failed after 3 to 5 years. So if some of the audience are professors, or some of the audience who are working in this field, I would suggest that please do a project in which you guys train the mason as well as the farmers, carried out the proper training of the farmers how to take care of the biogas plant, so that this technology doesn't fail again. If you go to the next slide, I will show the common problems which I have faced during that project. If you see this is one of the part in which we try to convince the farmers that please use the animal dung for anaerobic digester and make a biogas plant. But believe me, he doesn't convince. The farmers was conventional farmers. He preferred to store the woods instead of getting free gas from the digester. He when we try to convince him that you can get gas and you do not need a lot of labor to collect the woods and then to store the woods, but they didn't convince. Why? Because they were asking me that there was a farmer in my area who have used the technology and that technology failed. Why that technology failed? Because the mason was not expert, and similarly the operation and maintenance of the biogas plant was not done properly. Next, please. So these are the problems which we have faced in that project. Many problems in the performance of biogas plants can be overcome. How it can be overcome? We can make less complicated design of biogas plant. We can make high quality, user friendly technologies by design and layout of biogas for convenient work, by proper training and easy access to device, operational problems. Next, please. This is the training of the farmers, one of the project, and that was actually done in African region, where that technology was being failed again and again. Next, please. So during that project, we have seen that what are the common mistakes that are being made in developing countries. First of all, the feeding of digester after construction. Even if an expert mason have constructed the biogas plant, it's working very well. If the feeding of the digester is not good, it will fail soon. Similarly, use and maintenance of control valves. Some of the biogas plants, they are being failed due to this checking the leakage. Leakage is not being checked in most of the biogas plant. Use and maintenance of water drain. This is one of the part I will show you it, but it is very, very important. And many of the farmers in Pakistan, they are constructing biogas plants from non-technical persons, and they are not using the water drain. And then they are saying that that biogas plant is not working. Similarly, cleaning of the outlet, use and maintenance of gas stoves, gas lamps. They are not using proper gas stoves, gas lamps. Similarly, they are not using proper engines. Similarly, the upgradation process, they are not using the proper filters. They are not breaking the scum. They are not reading the pressure gauges which are being installed on the biogas plants properly. So these are the common problems. If you keep these problems, keep in mind and construct a biogas plant, I am 100% sure that the biogas story will be successful. Next, please. So the first common mistake which farmers are making in Pakistan is that when they are making a new biogas plant and when they are feeding the biogas plant for the first time, they are using old manure, not fresh manure. And they are feeding old manure and they are not mixing proper water with the manure. And if you have not proper mixing, you should keep 1:1. If you have 1 kg manure, you should mix 1 liter of water or 1 kg of water. And then you should mix it and then you should feed it inside the biogas plant. So please advise the farmers when they are constructing a new biogas plant, for the first feeding, use 100% fresh manure. And before putting the manure, mix 1 ratio of water with 1 ratio of the manure. After that, start the biogas plant. It will work perfectly. Next, please. Second mistake they are making, they are not feeding the properly. Please, during that project, we have done a survey, and most of the plants which are failed, the farmers, they are not feeding them on daily basis. For example, if they have a marriage function or some other functions, they are going to the function and they are not taking care of the biogas plants. But bacteria are very sensitive. They need feed material on daily basis. If you are not feeding it daily, it will destroy the biogas plant. Next, please. This is a common table. Please keep the table when you are constructing a new biogas plant. For example, if you are constructing a 50 cubic meter biogas plant for initial feeding, you should have 1400 kg of dung. 1400 kg for the first feeding. And then on daily basis, you should feed 400 to 500 kg of dung. And then on a daily basis, you will get 16 to 20 cubic meter of biogas. Similarly, on the 75 cubic meter and 100 cubic meter biogas plant. Next, please. And this picture I have put into the slide just to show you guys that when you are feeding biogas plant for the first time or on daily basis, please check your dung to water ratio. Take a stick and dip the stick inside the mixing tank. And there are two pictures here, on the right side as well as on the left side. If you see on the left side, the material, it has the proper ratio of manure and water. And if you dip the stick, the material will stick with the stick. And on the other side, if you see, the farmer has added more water in the manure and manure is not sticking with the stick. It means he has not proper ratio of manure and water. Next, please. This is the most common problem which I have seen in Pakistan. And please advise the farmers when they are constructing or feeding the biogas plant, they should not use too much animal urine in the manure, because greater the amount of urine in the manure, greater will be the inhabitants of ammonia inside the biogas plant, and it may cause the failure of the biogas plant. Try to reduce the amount of urine in the manure. Next, please. Similarly, when I visited different types of biogas plants in Punjab region of Pakistan, for what farmers are doing, they are not taking care. They are not proper mixing. If you see, they are mixing stakes, powders, and some other impurities. please advise the farmers that it can deteriorate your whole biogas plant. Your whole hard work can and go into the dump if you are doing this practice. Please advise them, do not use the impurities while feeding the biogas plant. Next, please. Similarly, the other things, don't connect the toilet if you are using high concentration of chemicals like Harpic, phenol, and Dettol. Next, please. Whenever you are constructing a biogas plant or feeding the biogas plant, please check there should be no heavy metals in the feeding material, no antibiotics, no detergents, no organic solvent. Similarly, bioindustry which are installing biogas plant should not use high amount of antibiotics. Toilet plants, they usually have the problem of antibiotics and detergents. Polluted water sources, industrial salts problem, and chemically treated water sources, they have the problem of chemicals. Next, please. And most of the plants which I visited, I have seen a common issue that some of the non-technical persons, when they are constructing the biogas plants, they are not using the main gas valve on the biogas plant. And if they have used, they have the issue when I checked with the leakage, it was leaking. And then they are complaining that the biogas plant is not producing proper amount of biogas. So please advise the farmers to have a main gas valve on the digester, as well as check the valve regularly whether it has leakage or not. Next, please. This is one of the leak test on the gas line. Please advise the farmers that regularly check the gas line. If there is a leakage, try to reduce the leakage problem. Next, please. This is the water drain. When we check most of the biogas plants, there was the water inside the gas line. Please advise the farmer, install a water drain in the gas line, because when the gas moisture usually collected inside the biogas plant, and that moisture stop the gas flow to the stove. So it is better to install a water drain inside on the gas pipeline, so that you can remove the water from the gas line frequently, so that there is no issue of the water gas stop problem. Next, please. This is one of the plants which we visited, and that farmer has an issue of the gas, and he has not installed the drain valve. Then what we did, we removed the pipe from the stove and we put the pressure on the gas, and then the water was removed, and then the plant was working fine. Next, please. Similarly, most of the farmers, they made a common mistake. They do not clean the outlet of their biogas plant. With the passage of time, some of the outlet may clogged, and the clogging of outlet may cause many issues. If you see the next slide, these are the issues. When your outlet is clogged, the outlet tank will also be cracked. If you see the pictures, some of the outlet tank, they are cracked, and some of them have the weeds issues as well. Next, please. Similarly, there are some farmers who are using the biogas plants, but on the gas stoves, they are not using that gas tap. So by the gas tap, you can regulate the pressure, or you can adjust the pressure of the gas. And most of the farmers, they are not using the gas tap. Please advise the farmers that use the gas tap, so that you can reduce the pressure or you can stop the gas incoming flow. Next, please. This is gas tap. Next, please. So this is the common problem which we have seen in Pakistan, and I hope that it will be the issue in Indonesia as well. What the farmers are doing, they are using the same stove for cooking purposes for biogas cooking as they are using for natural gas. Please keep in mind, the stove for the biogas will be different compared to the LPG or the natural gas. This is, if you see the most left hand side picture and most right hand side picture, the flame is going outside. Why? Because this is a natural gas stove and it was using for biogas, and that's why the stove was not touching the center of the uh, 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 cooking utensil, and that's why they are not getting the proper heat. Next, please. And similarly, when you see that there is a yellowish flame of the biogas stove, it means that there is a moisture in the gas. If there is a moisture, flame is not fully blue, please check your water drain and remove the water. And when you will remove the water, you will get the bluish flame. Next, please. Here, if you see the flame is also have the same issue, the yellow flame, it means there is some water in the gas. And these are in the next slide. If you see there, these are proper flames, these are blue flame, and there is no water. So, Budhi, can we discuss some of the questions, because I have a lot of field slides, and I think the audience have got some kind of knowledge, and
Okay.
now we can discuss some of the questions or
Yeah,
the
sure.
problems, so that we can have some good discussion as well.
Okay, okay.
But if you guys want a detailed lecture on this, I am always available.
Okay. So do you mean like we move to another PowerPoint now, or just discussions now?
I think discussion, because 2 hours, we have already 1 hour and 20 minutes. So 40-minute
Yeah,
discussion
I
will
think
be.
so, yeah. Okay.
Yeah.
So now Q&A. So for everyone who wants to ask, please raise your hand here. Is there anyone? So I think they're still preparing the question. Yeah, I mean, like that's so interesting, especially for the types of the digester. And then you already mentioned like every country has a different digester, anaerobic digester, and then
But as far as my knowledge, I have gone through some of the literature. The biogas technology is also not too much successful in Indonesia. It is facing the same issue as Pakistan. So beside this, I just want to let you know that I have there is about $36 billion of fossil fuel imports or petroleum product imports of Indonesia, which is a lot.
Yeah.
A lot. And there is only 10% renewable energy share in total energy mix of Indonesia. And same is the case with Pakistan as well.
Yeah.
We are 70% fossil fuels in energy mix of Pakistan, and they are only 7% of renewable energy mix. And the fossil fuel imports of Pakistan is $18 billion, almost half compared to Indonesia, but still it is a lot. We have to promote this technology.
Yeah.
We have to promote green energy technologies in our countries to overcome this huge amount of money. Believe me, if we will try to flourish this technology, we will train the farmers, we will train the people properly, this technology will be a success. Right now, the major issue of both the countries is that most of the plants, they are facing the same issues as I have discussed. Non-technical persons, similarly, the operation and maintenance is not proper. That's the major
Yeah.
reason of the failure of this technology. So I would like to have some questions.
So yeah, is there anyone here want to ask? I believe you yeah, you want to know more, and now is the Q&A. So please raise your hand if you want to ask some the questions here. Oh. Okay, George. Yes. Go ahead.
Okay, hello, good morning, sir, from Indonesia here. My name is
Yeah.
George. I'm from class 2023.
Yeah.
And I want to ask Sir Usman about the design selections. So in the design selections, you said that um, if we want to build a biogas plant, we have to have good soil conditions, right?
Yeah.
And I'm very intrigued about the good soil conditions. Can you tell me more the detail of the what is the perfect conditions of the soil if we want to build a biogas plants? And have you met a case where the biogas plants have a bad soil conditions? What happened if the biogas plant have the bad soil conditions? I think that's all my questions, sir.
Actually, I have seen some of the when I go through the problems which are being faced by biogas plants in Indonesia. It is the common issue. It is the common, no doubt, the most common biogas plant is fixed dome type biogas plant. But when there is severe weather condition, for example, high rainfall or other severe weather conditions, there is some cracks in the digester or there is failure of structure. And according to my experience, I would suggest that if some of the researchers or some government guys are listening the lecture, they should definitely test the prefabricated technologies. Prefabricated technologies will definitely be cheaper, not only cheaper for Indonesia, but it will also help to overcome the soil issues as well as the construction issues. For example, if there is soil issue due to flood, there is an issue or the soil on the sides leaves due to flood, but at least your digester will have so much strength that it can bear the weather conditions. So definitely I would suggest that prefabricated technology, which I have shown that it is very common, and it should be adopted in Indonesia as well. But the major issue here is that if you, for example, you are working, George, and you want to adopt the prefabricated technology in Indonesia, it will definitely be expensive because there is no company who is fabricating the plastic biogas plant in the Indonesia right now. I have seen. Yeah. So the major reason when I teach the course to my students back in Pakistan, and I used to ask them what you will do after doing your degree, and they ask, I will do the job. If you are all of you, about 58 students are listening us as an audience, I would suggest you, I would advise you that please do not run behind the job. Try to develop your own companies, try to do entrepreneurship, try to develop some kind of bioenergy technologies by yourself, try to develop a prefabricated biogas plant company so that this technology can become cheaper in the Indonesia and this technology can be developed. Yes, any other question, please?
So how's George? Do you have any following up questions, or that's good?
I think that's all for me. Thank you, Sir
Okay.
Usman and Sir Budi.
Yeah.
Yeah. Okay. Thank you. So yeah, another questions probably here. Okay. Steven, go ahead. I think you're still muted.
Oh God.
Yeah. Yeah. That's good.
Yeah.
Yeah.
Good morning, sir. Thank you for the opportunity given to me. So first, let me introduce myself. So my name is Steven Sumarmata and from Pajajaran University, Agro-Industrial Technology Study Program. So I want to ask something about the type of biogas plant. Uh, are all the biogas tanks planted in the ground with a little of the top showing to the surface, or some above ground? If so, why does it have to be planted in the ground? Thank you, sir.
Actually, the most of the biogas plants, they are constructed underground. Like I have shown you the fixed dome type. The most of the type domes are even buried in some of the areas in Pakistan, because the major purpose of constructing underground is that the to avoid severe weathers. If temperature is higher or temperature is very lower, and your digester is underground, the soil on the sides will act as an insulation, and it will not disturb the bacteria. The weather conditions will not disturb the bacteria, and they will perform better. That is why it is suggested that the most of the biogas plants should be constructed underground. But the one of the type which I have discussed with you, the floating drum type biogas plant, in that type of biogas plant, the digestion digester will be underground, but the drum will float above the ground. Drum will float above the ground. It will not inside the ground. But that technology is not successful, will not be successful in Indonesia, because the floating drum is made of steel, and in Indonesia there are a lot of rainfalls, and due to those rainfalls the steel drum will get rusted, and that when it will be rusted it will cause leakage. So the major purpose of making the biogas plants underground is the insulation and to avoid severe weathers. But there are some types like floating drum in which the drum is above the ground. But there are some parts of the world where the temperature remains same and there is not enough rainfall. They are using, even some parts of China, they are using prefabricated technologies, and they are keeping just like water tanks above their roofs, small biogas plants above their roofs, and they are just putting food waste or some other type of waste inside. There's a prefabricated small biogas plants, and they are getting gas for cooking requirements of daily basis.
All right. So how's Steven? The answer.
Okay, sir. Thank you. So it means to be able to balance the temperature so that it works more effective
Yeah.
if we okay, thank you, sir. Thank you for the answer. I can
Yeah.
understand. Thank you, sir.
Yeah. Okay. All right. Thank you, Steven, for the question.
Yes, sir.
So, is there anyone else want to ask the questions here? Hmm. All right. So, Usman, could you describe like little bit, because the example that you already mentioned in your presentations, most of them they are from developing country. So, how's the anaerobic digesters in the developed country, for example, in the United States or in in Europe, some countries in Europe?
Actually, in our region, our parts of the world, developing countries, the because government is not constructing the large biogas plant. If you go to USA or some European parts, actually the most of the biogas plants, you will not see the smaller biogas plants. They will be 300 cubic meter, 500 cubic meter, 400 cubic meter, or even 1000 cubic meter. And most of the private companies are also constructing with happiness. Why? Because these government have made the rules that government will buy the gas from them.
Oh, okay.
Yeah. So there are no smaller for house cooking. You will not see a single biogas plant who have a single household who has made a biogas plant for himself or herself. Most of the companies or large dairy farm, they have made 1000 cubic meter, 500 cubic meter large biogas plant, and they are selling the gas to the government, and government is paying high prices to them. But in developing countries, government is not providing such facilities. That is why most of the farmers, even the technology is successful, the government is not giving any subsidy to them. The government is not purchasing any gas from them. I'm 100% sure that in Indonesia, the Indonesian government is not buying the gas from the farmers. Same in Pakistan, government is not buying the gas from the farmers. And believe me, if today's Indonesian government make a policy that we will buy 1 cubic meter or 100 cubic meter of gas from $100, believe me, every farmer will happily install the biogas plant. And same will be the case in Pakistan. We are importing billions of dollar LPG from Qatar. But still, the government is sleeping, not making any rule for the farmers so that farmers can install biogas plant and we can overcome this issue.
So is it possible if we also can make for example the biogas like the LPG is kind of like the tank and then we can sell it?
That is not possible for smaller scale biogas plant.
Okay.
Only possible
in that tank,
because for liquefying, if you want to make CNG from biogas, that is compressed natural gas.
Okay.
If you want to make compressed natural gas from biogas, you should install a compression system that liquefy the biogas, and that biogas liquefy at minus 161.5 degree.
Wow.
It's huge amount of energy, huge amount.
Yeah.
And that can only be achievable if you are installing a very high capacity biogas plant, very high capacity. And that is why Europe is very successful in biogas CNG, because they already have 500 petrol pumps in Europe. Already 500 petrol pumps are installed who are converting biogas into CNG. Possible, but when you are constructing a biogas plant of very high capacity, not on small scale biogas plants.
Okay. Yeah. That's still possible.
Yes.
All right. So is there anyone want to ask here? I believe okay, Bianca. So go ahead.
Okay, thank you so much for the opportunity. So I have a question. First of all, my name is Bianca and I'm from Indonesia. So my team and I are currently doing a research about anaerobic digestion, and we have a question. In your opinion, can anaerobic digestion play a significant role in mitigating climate change? And if so, how does it contribute and what are the potential challenges? Thank you, sir.
Very good question. So actually, the most of the farmers in Pakistan as well as in Indonesia, they like to landfill the manure. They like to landfill the manure. Similarly, most of the restaurant and food industries, they like to landfill their food waste. Same is the case with the wastewater treatment plants. Most of the wastewater treatment plants, they like to landfill the sewage sludge. All these types of waste, when they are landfilled, they are emitting the greenhouse gases into the environment, like CO2, CH4. They are emitting in very high amount, and emission of these gases will definitely cause the climate change. But on the other hand, instead of landfilling, if you divert the same waste to the biogas plant, there will be no emissions into the environment, and you will get a clean gas as well. So definitely anaerobic digestion is a wonderful technology, and it can definitely overcome the climate changes. And you know an interesting fact, that a common Indonesian guy emit 2 tons of carbon dioxide into the atmosphere on annual basis. 2 tons, it's a lot. Okay, so 2 tons mean you are contributing significantly in climate change. But if you divert all these waste which we have discussed to the biogas plant, definitely there will be no emissions into the environment, and there will be no climate change.
All right. So how's the answer, Bianca? Do you want to ask again, or that's good?
Yeah, it's good, but just to wrap it up, so it's all about the methane gas that is like increased because of the farmers waste. Is that so?
All the waste which you are landfilling, they are increasing the amount of carbon dioxide and methane gas into the environment, and that is definitely causing the climate change. But if you divert the waste to the biogas plant, that emissions will not occur, and you will overcome the issue of climate change.
Okay, that's clear. Thank you so much, sir.
Yeah. Thank you, Bianca, for the questions. So is there anyone here again want to ask? Raise your hand. So I think there is the questions here from Muklis. Oh, yeah. Okay, after Muklis, probably, Faridan. So, may I ask, I'm Muklis from Department of Agriculture Industry Technology. And then I am sorry for not being able to turn on the microphone. In Pakistan, what are the main raw materials used for biogas production that greatly affect the results of biogas production, especially the perfections of the composition of methane gas and flame, because not all materials have good results. So what is the best raw materials there in Pakistan especially?
In Pakistan, still the most common types of 90% of the biogas plants still working on the manure. Still working on the manure. But there are about Pakistan is the about fifth largest producer of sugar. So all the sugar industries, they have installed. Currently, Pakistan is undergoing some energy crisis, especially the gas crisis. So most of the industries, they have installed their biogas plants, and they are using sugar industry waste as a feedstock for biogas production, and it is giving wonderful results. Wonderful results. If you have sugar industry, it's a wonderful waste, believe me. Similarly, you guys have a palm oil waste.
Yeah.
So palm oil, similarly, you guys have rice, a lot of production of rice.
Yes. Mhm.
But these two materials are not easily digestible.
Mm.
But the wastewater or the waste sludge from the palm oil industry,
Mm.
if properly mixed with rice straw, properly,
Okay.
then there will be much better results, like manure. Manure, no doubt, is the best material for the anaerobic digestion, but because we have to overcome the other waste, we should definitely test this technology for the other waste as well.
Yeah. Because it contains like the combinations of the fats and then the
Exactly.
sugar, so that's why the microorganisms like methanogens so happy to eat
Yes.
the kinds of the waste, right? Yeah.
Yes.
Oh, nice. So, okay, Muklis, is it good? Or you have like the following questions here? Okay, thank you, sir, for the answer. Yes. So now we move on to Faridan. So, hello, Faridan. Are you there?
Hello,
Okay.
sir.
Hi, hi.
Uh,
Yes.
First of all, I want to uh, introduce myself first. My name is Faridan Ahmad Kurnia, and I'm from Pajajaran University, Agro Agrotechnology of Industry, class of 2023. Okay, so I want to ask. So you've mentioned a lot about the use of biogas in uh, country level, even here is in Indonesia or in Pakistan. And that's make me want to ask you about what are the minimum quality or quantity standards for biogas to be suitable for nationwide use. Maybe that's my question, and thank you.
So it depends on the usage. Depends on the usage. For example, if you are using biogas for cooking purposes, as I have told you, when the biogas is coming out from the biogas plant, it contains two major components, methane and carbon dioxide. Okay. So there will be 60% methane and 40% carbon dioxide. If you want to use the biogas for cooking purposes, you do not need any standard. You can directly use it for cooking purposes. But if you want to use it for producing electricity, for example, you want to run a generator on this gas, then if you will use that gas directly to the generator, the carbon dioxide, the moisture, the hydrogen sulfide will deteriorate all the parts of the engine. That is why it is necessary to remove the impurities. There are three major impurities in biogas: carbon dioxide, hydrogen sulfide, and moisture. These three impurities must be removed before using it into the generator. So it is usually recommended, yet if you want to use the biogas in the generator, the minimum concentration of methane should be 80%. Should be 80%. Okay. So at least 80% if you want to use, but in developed countries they are bringing it up to 99% as well. 99%. But for purifying up to that level, there will be a huge cost. So because in Pakistan and Indonesia, still the conventional methods are being used for carbon dioxide removal, that can only bring the methane level up to 80 to 85%. But that level is very good for running an engine. Is it
So,
good or not?
so how's the answer?
It's all clear, sir. Thank you, Sir Usman and Sir Budi.
Yeah, you
Okay.
are most welcome. You are most welcome.
Thank you, Faridan, for the questions. So we actually still have sometimes here. 13 more minutes. Anyone want to ask the questions again?
Should I ask the students some question?
I think so. You should ask the probably can ask some question to the students now.
Okay, so most of the students are from agro industrial technology. I just
Yes.
want to ask you that how much population of the Indonesia is involved in farming or in agriculture?
In
How
agriculture.
much? Yeah.
So is anyone want to ask here? I think
A
they
simple.
uh-huh. Someone's I think turned on. Probably can ask. I think no one's want to ask here. To answer it.
Okay, Budi, at the end, I would like to give you some suggestions.
Okay, sure.
Your faculty members,
Mm,
please do such type of projects. But your country needs a lot like these projects, in which
mm,
especially you construct some of different types of biogas plants, like prefabricated one.
yeah.
And I think the membrane technology is not so common in
Mm,
Indonesia.
mm.
Membrane technology should be tested in Indonesia. It is a very good technology and it can reduce the cost of digester as well.
Okay.
Similarly, please ask your faculty members, or you should
Mm-hmm.
write a project in which you will train the farmers as
Mm-hmm.
well as the industrialists or some of the guys who have already biogas plants,
Mm-hmm.
how to take care, how to I have done 2 to 3 projects. If you guys need any help, I am available.
Yeah,
Okay.
thank you. Yeah,
Yeah.
sure.
So arrange some type that type of project so that this biogas story can be made a success story in Indonesia as well.
Yeah, yeah. I think the biogas is good for the business too, right? Like especially for the students here who wants to be like a technopreneur. So yeah, I mean biogas in Indonesia actually still I don't know, probably like left behind your
Underdeveloped, still like
underdeveloped.
yeah.
Yeah.
Biogas technology is underdeveloped. It is a success story in China. It is a success story in India. It is a
Mm,
success story. It is now becoming a success story in Nepal. Why I have
okay.
discussed again and again. It is
Mm,
becoming a success story in Nepal. It is becoming a success story in Bangladesh as well. We
mm-hmm.
will have to learn lesson from those developing countries, and we
Mm-hmm.
will have to proceed a step higher to promote this technology in our countries as well.
Yeah, yes, yes.
i
Yeah.
think i think some of agro industrial engineering students should come forward. They should make their bioenergy companies. They
Yeah.
should develop some kind of their own design,
Yeah. Mm-hmm.
and then definitely they can talk with the government official that this technology can be flourished, and in this way that technology can be flourished.
Yeah, yeah, sure, sure. So,
Now there is an era of social media.
mm-hmm. Mm-hmm.
Even if somebody is not supporting you, you can put your technology on social media, and believe me, you can get good results.
Yeah, yeah, yeah.
If your country is not supporting, might be some other countries willing to adopt your technology.
Yeah.
So your hard work will not be unfruitful if you do the hard work.
Yes, yes. That's actually a good business idea, especially for the bioenergy, like because it's not only like about especially in our department, we just focus on the other things, for example, like the food business and then like essential oil business, but we still haven't developing like the bioenergy business, and biogas is one of the potential one, I think. Like yeah, here there are a lot of students from our department, agro-industrial technology department, and then so we are prepared for being an entrepreneur, technopreneurship. We actually have a lot of courses related to technopreneurships too. Then yeah, So bioenergy or biogas is one of the potential business, especially. So you are the next generations for yeah, this area, I think.
Yeah, yeah. You have the potential, dear all. You have the potential, and believe me, try to do so your final year project. And I have motivated my students, and believe me, they have made a wonderful design for Pakistani family who want
Yeah,
to cook, who want to produce biogas for 5 to 6 family members. I
yeah,
would suggest you a title that try to make a design of biogas plant in your
yeah,
final year project, and
yeah,
then
yeah.
try to patent that technology as well.
Yeah, yeah. So that's really good. That's really good
Yeah,
idea. That's really good
yeah.
idea. Thank you, Usman, for bringing it up here. So yeah, yeah. Thank you so much. And so, is there anyone want to ask other questions here? So we still have a couple minutes now, 7 more minutes, I think. No? If there is no questions, probably we can end this lecture. So thank you so much, Usman, for the
Most
great lecture. And then we actually already learned a lot of things from you, especially about the biogas productions, and then the biogas plant facilities, and the problems, the current problems, especially in my country. You also discussed about the problem in our countries too, about the biogas
yeah.
productions here. And thank you so much. And here there are a lot of students, and then the students also already get like some idea for the business there, bioenergy business. That's really great. And probably if the students want to, for example, they have like something on their minds, probably can email you, right? So
Most welcome. Yeah, if
yeah,
any of the student who is doing his project or who has an
yeah,
idea, he
yeah,
can
yeah,
directly email me.
yeah.
At the end, we have 5 minutes. I would just let the students know what are the reasons of
Mm-hmm.
failure of this technology in Indonesia, so that
Mm-hmm.
they can overcome. If any of you who want
Mm-hmm.
to overcome these reasons or can help the Indonesia, that would be wonderful.
Mm-hmm.
The first reason is
Yeah.
the lack of awareness.
Mm.
Lack of awareness, believe me, your
Yeah.
farmers are still lack of awareness. Please, when you are doing internship or doing some project, please advise your farmer that it is a wonderful technology and they should adopt this technology. And second biggest reason of failure is technical reasons.
Yeah. Technical
Still,
reason.
still there is a technical shortage. I would suggest your department to include some bioenergy courses, especially dealing only on bioenergy, so
Yeah.
that students can have motivation and they try to do research in this field,
Mm-hmm.
so that more technical persons can be produced. Your university can also arrange a short course of 1 to 2 months if they
Yeah.
are doing short courses on bioenergy as well.
Mm-hmm.
I can help the university.
Oh, thank you so
Yeah.
much. Of course,
And
we will connect you
yeah,
with our university.
and the third biggest reason is economic reasons
Yeah.
that can only be overcome if this technology and there is an entrepreneurship in this field.
Mm-hmm.
Please come, dear students, come forward and try to develop your company so that this technology become cheaper and every farmer willing to adopt this technology.
Mm-hmm.
There are some social barriers as well,
Mm-hmm.
because the people who are living in city, in the capital of Indonesia, they would not like to play with waste. Yes.
Yeah, yeah, I know. I understand.
Yeah.
Yeah.
So you will have to give social awareness of this technology.
Yeah, you're right.
And the next reason is policymakers. Policymakers in Indonesia and Pakistan, they are sleeping.
Mm.
You can only convince through your research. You can only convince the policymaker through your research that we can overcome the import of oils by adopting green energy technologies.
Mm-hmm.
And the next is market barriers. There is not enough market which can make this technology
Yeah, of course.
cheaper.
Yeah.
So we will have to develop this market.
Yeah.
Farmers' lower acceptance rate. You will have to convince the farmer through success stories. In this way, they will be willing to adopt this technology.
Mm-hmm.
And unrealistic expectations. Please do not have unrealistic expectations until and unless you do the proper operation and maintenance of your biogas plant.
Mm-hmm.
You will have real expectations if you are constructing biogas plant with technical background, with very good feeding material, then you will have some wonderful results.
Mm-hmm.
Yes. So that's all, dear students. And if you have any question, any concern, and you are
Yeah.
most welcome anytime.
Yes, yes. Probably I can share your email to my students too, right? Like or
Most,
the
most welcome. Most
yeah.
welcome. Most welcome.
Sure. Okay, thank you so much, Usman, for today. And we
Yeah.
actually have a certificate. So, Muklis, are you still here? Probably you can show the certificate for our speaker today. All right, Muklis, try to share the screen now. So we actually only have the certificate here for you, Usman. Yeah.
No problem. Thank you very
Okay.
much.
Yeah.
Thank you
Thank
very
you
much.
so much for today.
I would like to thanks to the university as well as the department for giving me this opportunity.
Thank
And
you
if
so much.
you need any help in the future regarding this technology, I am more than happy to assist you guys in this
Oh,
technology. No
oh,
problem.
thank you so much. And probably we will have the new collaboration with you, and then I will put in contact with our department as well, and then we can, make us some projects to about the
Yeah,
biogas. I think that's so
yeah,
interesting, right?
yeah,
That's
yeah.
yeah.
Thank you
So
very much, guys.
thank you so much. Thank you so much for the talk today. So okay, probably we can end this lecture, and
Thank you so much.
yeah, we will have another lecture next week. Usman's friend, Dr. Alnur Al-Bukhari, will talk about membrane bioreactors. So that's so interesting. Usman already mentioned about the membrane itself, and then Alnur will combine it with the bioreactor. So that's so interesting lecture, I think. And especially for next week, we will start it at 8 a.m. In Indonesia time. So here today, so a little bit late because I just knew it, and I'm so sorry for being late today. So for next
No
week,
problem. But
uh,
did we get the same number of students as we did in the previous lecture or somewhat less?
oh, I think here little bit less. Yes.
Okay.
Yeah, we sometimes we already get like 100 participants, but now just 60 something. But it's fine. It's not
Yeah.
only the students, by the way, but this is for public. Like probably like some people here also from the other universities and then other countries. So I also saw some people here. Then we are so diverse today. So
Yeah.
thank you so much, Usman, for sharing.
You're
Then
welcome. You're
yeah,
welcome.
we can continue for the next lecture. Thank you so much.
Bye bye. Bye bye.
Bye
Bye
bye.
bye.
Bye bye. Thank you so much. Bye bye. Yeah. Okay.